Hi everyone, I am Dr. Vimala Roselin. I am Assistant Professor in Kristi Jayanti Institute of Technology. I am going to explain about the convolutional neural network applications, CNN applications. So here the applications they mention in image classification, object detections, and segmentations. So CNN, there are lots of types of CNNs are there. So, but in our syllabus, we are going to study only a few CNN concepts. First one is an AlexNet and VGGNet and ResNet. So, in these sessions, we are going to see about the AlexNet. So, AlexNet is one of the convolutional neural network. This is used for the image classification. And AlexNet is an deep learning model that made the big impact of the image recognition. And it becomes the famous to classify the images accurately. This is the architecture for the AlexNet. So, it is used to GPU to boost the training performances, and it consists of five conventional layers and three maximum pooling layers and two normalization layers and two fully connected layers and one softmax layers. So each convolutional layers, five layers among each layers consist of convolutional filters and non-linear activation functions called ReLUs, rectilinear unit activation functions. The pooling layers are used to perform the maximum pooling functions, and input size is fixed due to the presence of fully connected layers. The input is 20 to 224 into 224 into 3. But due to some padding, when you are using the padding, it happens the workout to be 227 into 227 into 3. So some key features for the so here the architecture they given. So five conversion layers and two fully connected layers and one output layers. So here they also divided the filters like this only. So 11 into 11, that is a convolutional layers, and here they're using the 96 filters, and strides is a 4. So in between the two convolutional layers, one maximum pooling layers are there. Each and every pooling layers has 3 cross 3 and strides is 2. And after five conventional layers, one is a maximum pooling, another maximum pooling will be there. That is called as an maximum pooling layer. That is 3 cross 3 and stride is 2. And after that, the image will be go to the fully connected layer. That is an first layer. Two layers, fully connected layers are there. In the first layers, that pixel size is 4096. And in another fully connected layers, that is pixel size is 2004. 4096, and after it is converting the image recognition, it will send it to the output layer, and then it will go to the softmax layer as a particular image. So here some key features are given. So here we are using the activation ReLU activation layer. So it is used to um, used as an activation functions rather than the RAN-H. So here what are the convolution layer, how many layers they use, the filter, how many filters they used for the AlexNet, and what are the strides, all the details are given here. And features, first feature is overfitting prevention. So it is applied to the first two fully connected layers, and the data augmentation dynamically expanded to the data set, hence both helping in reducing the overfitting. Fast training, why is a fast training? See here we are using the ReLU activation functions that is used instead of tangents or sigmoid function. It is leading the 6 into speed up in the reading and avoiding the activation saturation. And another feature is five convolutional layers with the maximum pooling. It is applied after the first and fifth layers to enhance the feature extraction. In a feature extraction, say cleaning and everything will be there. And overlapping maximum pooling, it uses the 3 into 3 filters with the strides too. And it is used to improve the performance by reducing the top one error by 0.4 percentage and top 5 error by 0.3 percentage compared to the non-overlapping pooling, and followed by two fully connected layers. Each layers is used to prevent the overfitting, and finally one softmax layers are there for final classification. So here some advantages given for the AlexNet. First one, use the ReLU activations. So first major architecture, it is used to ReLU rectified linear unit used instead of TANH activation layer. Why? Because that is used to enable the faster training compared to the traditional one. And drop out the regularization, it is used to drop out the layer to reduce the overfitting by randomly displaying the neurons during the training. And GPU utilization, it is splitting the network across the two GPUs and showing how the deep learning can benefit from the parallel computing for faster training. And overlapping maximum pooling, it is used to overlap the pooling layers to improve the generalization, and it is reduce the top one and top 5 classification error. So some disadvantages also is there in the AlexNet. First one is large model size. So it has around 60 million parameters, making it the memory intensive, and it is very slow for the interference within the low resources devices and high computational costs. Um, that even it is optimized for the GPU, it is a very expensive and manually architectural designs. It lacks the modularity and automation. So it is and next one, not optimal for small data sets. This is for the big one. This is not for optimal for the small data set like CAFA or 10 or Minister. Then outdated compared to the modern architecture, lacks innovations like residual connections, depth-wise separable, convolutional, mobile data, and attentions in the VAT. So these are the disadvantages. So Alex is a very, very important one type in the convolutional neural network. Thank you.